I'm Eric Horvitz. I'm the director of Microsoft Research Labs, which includes labs around the world. It's interesting, I came to Stanford as MD, PhD in neurobiology. My goal was to really deeply understand mind and cognition. In my first year at Stanford, I made a commitment that the way to go for insights would be computational, and dove hard into computation. But I've always been deeply interested in the magic of mind. What are the computational principles? How on earth, eventually, maybe in the future we'll get into this as scientists, but how on earth do assemblies of neurons lead to this fluid experience that we have? And what are some foundations and insights and experiments and models along the way? As a young boy, was exposed to anime cartoons showing robots like Astro Boy and Eighth Man, these beneficent machines with electronic brains. In the 70s, late 60s and 70s, we were in this world of where I think there was a discovery and interest in electronic brains, given the advent of computers in the world. I think that framed a lot of speculation. And I do recall trying to build an electronic brain myself out of parts. And I thought this would take me more or less a few days. Here I am. That was first and second grade. And here I am a few years later, and we haven't made a lot of progress, but we're getting there. My deepest interests are in models of cognition that bring together multiple competencies, in particular this idea of weaving together competencies into a symphony of intelligence through meta-reasoning and control of the precision and nature of cognition along different dimensions. It goes back to my deep interest in this notion, which it's kind of framed by an evolutionary argument, which is one of how do we create bounded, optimal reasoning systems, imagining that we just can't do it all. We're always under limited resources. Is there a theory of intelligence that in some ways is framed by limitations and abilities, but still optimizes what can be done given the computational substrate available? So it's this whole idea of reflection, control, reasoning under limited resources to maximize expected value of action in the world as a model of intelligence. The way I view it is it's a model of rationality overlaid on top of computation. One phrase that I like to use is computational rationality. Just like Turing took some basic ideas about mathematics and theorem proving and imagined what it would be like to view these challenges from the point of view of a mechanical machine or an automated reasoner applying computation to math. Now we're looking at the idea of we'll take normative models of decision-making, probability, utility, action sequences in the world, and then say, well, how would you compute these things with a limited processor? Is there a model of intelligence that arises when trying to sort of squeeze the need to optimize action in terms of expected value with some notion of an objective function into the world of limited computation? So stepping back for a second and thinking about your earlier question, this idea of bounded rational agents led me to be very interested in this notion of AI in the open world, where the agent itself is very limited compared to, and its representations of the world are very limited compared to the complexity of the actual world. The ability to take ideal action means action under uncertainty, given the complexity of a surrounding world. And this led me to start thinking deeply about what were principles by which systems would know their limitations, automatically know competences, for example, in inferences when they take action in the world, to understand their own blind spots when it came to taking action. When I was AAAI president in 2008, 2009, I made the theme of my presidency AI in the open world. And what I meant by that was, let's start with theoretical principles, but also think deeply about implications of taking our limited artifacts and prototypes and systems we actually field, and understanding more deeply what they mean when they run in the open world, deeply in society, how they affect people, how biases and blind spots might show up in ways that might surprise people, what actions and systems might take that might lead to inadvertent costs that weren't thought deeply about in advance. So I like this whole idea of starting with trying to understand limitations of systems as a theory of intelligence, realizing that these systems are acting in the open world, in complex worlds that they can't possibly represent for the level of detail you would need to do something ideally, and taking that into the actual open world that we build systems to operate in, and thinking through the societal, social implications, costs and benefits of having these systems be in the world with people. Well, I think that we're just getting going on deep applications of systems you would call AI systems. Of course, AI is a broad term. I could say AI refers to a rich set of subdisciplines of computer science, some which date back to the time of von Neumann and Turing and so on, optimization, decision processes of various kinds under uncertainty. So it's a broad area. In many ways, these systems have been around for many, many years. In other ways, when it comes to systems that act more like people, getting into the realm of intellect that people are used to seeing people working in, that's a little bit newer. So what do I see? Well, some applications are coming to the fore quickly. Let me start with some competitive terrain. So we're in a world now where we have some major IT companies fielding technologies where we see an initial application of AI, often one under the hood, is one of using large amounts of behavioral data, which are now available through web interactions, being used to power machine learning that's aimed at enhancing engagement, making systems more sticky, getting more attention on computing systems. So I've been concerned with the early uses of machine learning and decision-making as applied to some obvious revenue maximizing goals of large corporations and small ones alike. One direction and a concern that I'm trying to keep abreast of, and I think that we as a society have to be thinking deeply about, is the use of data-centric analytics, predictive models, and intelligent decision-making from the point of view of the owners of these systems to maximize the duration of engagement and maximize revenue from end users, from consumers. These systems tend to, what you might say, hack human attention, hack human cognition, figure out ways that people might not even understand or realize why an application all of a sudden is very sticky, or we want to return to it more. There are some basic findings in psychology as to how to make something a little bit more sticky or addictive or intriguing in terms of policies for reinforcement, for providing some pleasurable views, social signals. You couple that with large amounts of behavioral data, and all of a sudden we have personalized attention magnets. And do we want to spend our time this way? We have to ask questions as humans. What's the good life? How do we want to spend our attention? Given the portfolio of things we can be doing when it comes to being immersed in a world where we have now algorithmic optimizers using the latest and greatest per the competitive terrain of AI to try to keep our minds on a stream of activity that is aligned with revenue to the owner company.
So this sounds a little bit scary in the sense that optimization can make anything better. And in this case, the thing we're making better isn't necessarily well aligned with personal agency or personal quality of life. I wonder how, as a society, do we make our way through that? Is it about design ethos for engineers? Is it about governance of companies? How do we get companies to use AI in a way that's more pro-social?
So I think when it comes to this particular problem of systems that are optimizing the values that are not exactly aligned with potential values of humans that are using them, I think we as society have to start really thinking deeply about the optimization models and the values and objectives behind them in systems that might not align with the values of the end users. And this goes the spectrum of many applications and services where AI technologies and various kinds of automation are being fielded. We have to think deeply, okay, what's the value function? Whose is it? And who is the agent, or who's the principal agent behind the decisions, the action sequences that are being emitted by these systems, whether it be a self-driving car or an online social media site. It's interesting to think about responsibility. My own sense on this is that we have multiple players that need to be responsible. We have the need for corporate responsibility. We have the need for deep scholarship in academia and in industrial research labs to understand various trends and phenomena better. And we probably have the need by governments to come up with regulations that are in line with value to end users, customers. And from the point of view of citizenry, an educated citizenry is required to demand these kinds of responsibilities, whether it be from companies or from governments. I do believe that someday we'll need to have regulations in place that require disclosure of value functions and disclosure of algorithmic optimization of various kinds of goals through actions that might manipulate people and their minds, including what I would call attention hacking, figuring out what might increase the intensity of engagement and the duration of engagement with services and applications.
Is AI different? Is it change the game in some way that's disruptive and not just an evolutionary step in the same direction as a great marketing person?
There's been oversight and awareness over the years about propaganda and marketing. Of course, those are similar concepts referring to different, and that connote different kinds of things about the intention. But they're all about manipulation of minds. While you might say that sales and marketing and propaganda, depending on motivation, have been around for a long time, I view that work to date as being, yes, powerful, but back of the envelope. There have been regulations over the years, even, for example, it being deemed that marketing smoking and the wonders of smoking through beautiful, we'll call it propaganda and marketing about what it was like to be a smoker were banned. But moving to algorithmic manipulation, whether it be for maximizing attention or doing new kinds of manipulation when it comes to persuasion and believing, changing, for example, voter patterns, voting preferences, I think that there's something quite frankly scary about large-scale analysis based on great amounts of data that teach our machines new tricks when it comes to understanding the back doors into human cognition in ways that the end users will not understand. You know, I remember visiting my sister, who lives in a very tall apartment building in New York City, in Manhattan. And as the sun set, looking out across the way at another apartment building, I saw all these shadows, silhouettes of heads in front of cathode ray tubes glowing with, the fluorescent glow of people stuck to cathode ray tubes. And I thought to myself, wow, it's interesting how there's definitely heuristics involved in making shows and evolving them to make them sticky and stay right here, don't go away, in terms of getting to the point of the show that's really interesting when you want to sell a commercial. That was scary enough, and the idea of large-scale media doing it to these populations was rather chilling. But I just think that there's a whole new level of manipulation coming in waves where there are cognitive principles being learned by AI systems, even beyond our psychological theories that we know and explore in cognitive psychology, that will take it to new levels. Yeah, I do think that human beings, we know from over 100 years of fabulous and interesting cognitive psychology results, we have biases and blind spots that are well characterized. These characterized quite well in small studies, small n, over time. And you can imagine machines, AI systems, learning more deeply about our own personal goals, what we want to do, what we want to achieve as human beings, and also understand our limitations, and then work with us to help us to achieve our goals, to become happier, to be well, to seek new kinds of peace and contentment and achievement. As a physician, we don't want to make errors when it comes to high-stakes decisions that might affect patient outcomes. We know right now, per at least one recent study, that over 200,000 people in the United States alone are dying in hospitals because of human error. And you can look at the various studies. Some say 100,000, some say 250,000. But these are like cities the size of Oakland or Miami disappearing every year quietly without headlines. You can imagine systems that are just built to be cognitive safety nets in complex areas that really empower people to better understand, to continue to learn, and to catch errors that might be have high cost, high stakes. There's a prospect that systems can augment human intelligence in very, very deep ways that are based in not just human limitations, but in your limitations as a human being, to understand what you want to achieve, what you want to learn, that continue to have a dialogue, whether it be implicit or explicit with human beings, but how it's going. This idea of not just a coach that helps you through hard decisions in life when it comes to personal and professional decisions, but also just sort of empower you to learn more, to engage you about what you really want to achieve in life, to understand your ups and downs, your moods. There's a real prospect at building systems that deeply complement people, personally and professionally. Now, the idea also would be how to do that well, how to do that in a way that's fluid, not like a paper clip popping up on a computer screen, or a clunky assistant as it exists today in one or more devices you can purchase. But thinking out over the horizon into this idea of a mix of initiatives between an intelligence and you in a way that's trusted and that's oriented towards your preferences. Autonomy in automation has been a long-term goal in many areas. Our team developed one of the AI systems among hundreds that are under the hood that we don't really see as systems in our life for Windows. So the Windows operating system has something running in it called Superfetch, which is learning about you, the user, and learning to predict what you're going to do next in the operating system, and taking the next actions to pre-compute, preload with information, pre-render, so that you touch something and it's already rendered, it's there, with idle time and idle resources available between activities that the system is focused on. That's automated. It's completely automated. You don't want to be involved in that with oversight. Although if it's doing odd things, you might want to give it feedback and some oversight and control. There are some areas where automation will be appropriate with some high-level controls and understandings and education. There are other areas where it might be inappropriate. So, for example, there's been a bunch of discussion about what does AI mean for military applications, these very high-stakes situations. What does it mean on the battlefield? What does it mean in other kinds of high-stakes areas, even in medicine, for example? This idea of designing some systems to have meaningful user oversight and control is an important one. Thinking deeply about where we need to have human oversight and control, where we need to have people inspecting objective functions, understanding limitations of AI systems, looking out for biases and blind spots of the form that machines might have and might not realize. I have some personal stories and experiences with my Tesla, for example, which I was so excited about as an AI researcher. You know, here it was, semi-automated. I got it, had my Tesla for a couple of years, and all of a sudden they downloaded software as they promised, and one day the steering wheel started doing its own thing when you told it to just go for it, and braking and accelerating, and I was very impressed by this. But then I came to realize that there were things that the system didn't recognize that I recognized that led me to stay really alert to grab control of the system when I had to, because it was pretty clear the system didn't understand even some common sense notions like this idea of orange cones at nighttime coming across the left lane of a highway and closing it off. There I was at night, booming along, listening to stereo music with a fellow hockey player coming back late at night from the Everett Comcast Arena. And we basically looked out, and we said, hang on a second, because we were just talking. I was very impressed. I was showing him my very impressive car. I noticed orange cones in the distance. And I said, well, what's my car going to do in that situation? I have no idea. I'm curious, like to find out. I waited a little bit, and I said, nope, it's going to hit him head on. So I just grabbed and took over. Well, that's just an example of for years to come, maybe forever, situations that our AI systems just don't understand as deeply as humans. Now, of course, it goes the other way as well. You know, AI systems might understand certain things like errors in hospitals that humans aren't so keyed into, even human experts. But certainly, we want to think about, I think, an ideal path forward is our systems that really work really well with people at different levels of autonomy depending on the application, but that always allow human common sense, human sense for wise actions, caring actions to other people to play a role and to deliver oversight to larger ecosystems of AI and human intellect. So I'm fundamentally an optimist, and I believe that AI will deliver great value to human beings and to society. But like fire, which you might say generalizes to electricity and modern medicine and our scientific understandings, it can be used in many ways to harm, to burn down, to build weapon systems. And AI is no different in that it can be harnessed in a myriad of ways. I do believe that the human spirit will lead it to be harnessed in mostly good ways. We have to sort of always be aware it's a new technology. It'll be applied in ways that might be premature. It'll be applied in malevolent ways, depending on who's controlling the system. We have to also think deeply about how it's going to fold with different cultures and governments. One of my deep concerns is that authoritarian regimes can use these systems to really survey and suppress people in new ways, really infringe on human rights, freedom of assembly, freedom of expression, because the power to monitor, for example, at a distance, even among large crowds, as what each person is doing and who they are with just a small CCD is astounding. And so I think that we're going to have to sort of be cautious and watch how things flow, to be vocal, to be activists when it comes to, especially for scientists who have a sense for how technologies might be harnessed, to be sensitive and to warn and to engage across stakeholder groups to help ensure that things go to the side that I would call the optimistic side, the side that's going to deliver lots of value to human beings.